Hey guys, welcome back. So what we're looking at today is 6.2, is it right? So for this first part here, we're finding the distance using the Pythagorean theorem. So use the coordinate grid to find the length of each side of the triangles provided. Give answers in the exact form and where necessary, round to the nearest hundredth. So for number one, finding our side lengths. So to find this side, we can just count it. So 1, 2, 3, 4, 5, 6, 7. So we've got a side length that's supposed to be a 7 of 7. This side over here is 1, 2, 3, 4. So the legs of our triangle are 4 and 7. And so then using the Pythagorean theorem, we can find the other side rather than using the distance formula, which involves a little bit more work. So 7 squared plus 4 squared equals x squared. 7 squared is 49 plus 16 is what 4 squared is, equals x squared. 49 plus 16 equals 65. So we have 65 equals x squared. We take the square root of that. And so our answer, the square root of 65, is 8.06 equals x. So our three side lengths are 4, 7, and 8.06. So in most cases, your hypotenuse is going to end up being a decimal, so make sure to round that to the nearest hundredth. Okay? So same idea for 2, 3, and 4. Careful on 4. You know what this base is and you know what this height is, but to find the hypotenuse, these two sides, look at only half of the triangle, and then those two sides will be the same. All right, for the next part, number 5, we're looking at slopes of parallel and perpendicular lines. So on number 5, it says graph a line that's parallel to the given line. So first and foremost, let's figure out what the actual line is that we have. So our slope, it looks like we're going up 1, 2 over 1. So y equals 2x. Our y-intercept is right here at this point, which is at -2. So the equation for the given line is y equals 2x minus 2. Now, to have a line that is parallel to this, we have to have the exact same slope. So to write our slope, we'll have y equals 2x. And now here is the wonderful part. You can pick any number that's on this graph aside from -2. So I'm going to go with +2. And then to graph this, we start at +2. Let me make this a little bigger. We start at +2 on the y-axis, and then we go up 2 over 1, up 2 over 1. We come back down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And there is our parallel line. So, like I said though, for these, you don't have to have exactly what I put here. You could put +3, +5, +6, -6. Any of those values, so long as it's on this graph so you have an easy time graphing it, will work as long as you don't say -2, because then they'd be the same line. All right, so now what we're looking at is graphing perpendicular lines. Perpendicular. So your keyword for this lesson is perpendicular. So first things first, figure out the equation for the given line. So it looks like we're going up 1 over 1, 2, 3. So we've got a 1/3 slope for this. So y equals 1/3 x plus our y-intercept is right here at 1, so +1. Now, to make a line that is perpendicular, the key thing about it is the slope. Perpendicular lines have opposite reciprocal slopes. What that means is our slope on this line that we're given is positive. That means on our new slope, we're going to have a negative slope. And reciprocals, 1/3 and 3 over 1, those are reciprocals. So these are an example of reciprocals. So our slope here is just 3x. So y equals negative 3x. Now, the beautiful part about perpendicular lines, we can pick any number for our y-intercept. It doesn't matter. So I'm going to go ahead and say 1. You don't have to. You could leave it as just y equals negative 3x. That would be perfectly acceptable. Now to graph this out, so starting point is here at the exact same point as the other one, 1. But now I'm going to go down 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. Come back here and go up 1, 2, 3, and over 1. Up 1, 2, 3. I know it went off the graph, but oh well. And so there is our perpendicular line. And if you look, you can see that these are going to intersect at a right angle. So you know you have that perpendicular line. But remember, perpendicular lines have to have opposite reciprocal slopes. Okay? All right. The last section is looking back at solving equations. So the first two are solving basic equations for a single value. But notice 13 and 14, these are literal equations, which means you're going to take and rearrange them to get a single variable by itself. So we're going to do 13 together. Our goal is to get x by itself. So the first thing I'm going to do is I'm going to divide away this m. That way I don't have to worry about distributing it. Now, you could have distributed it first. That would have been fine. There's more than one way to take and do this. So we have y minus 5 over m equals x minus 2. Now, like I said, the goal was to get rid of everything with the x. So we have to add 2. This cancels. So x equals y minus 5 all over m plus 2. There's our answer. So it's all about rearranging it to get that variable by itself and doing opposite operations to do so. Okay? All right, if you guys have any questions, feel free to ask.